In this video, we are going to talk about how eigenanalysis may be used in statistics. Here we shall use a toy data set that we shall create right now and illustrate the method using that toy data set. It is going to be a sequence of videos. In the first video, we shall focus on only creation of the data set. So let's get started. The very first line, I have x equal to r norm 100. We are using r. So x equal to r norm 100 will generate random normal number, standard random normal number, and 100 of them. So let's just see what it has created. X are these 100 random normal numbers. So let's understand this. Suppose I say r norm 3. This means generate 3 random normal numbers. If I execute it again, I will get 3 other random normal numbers. These are supposed to be IID normal 0, 1. Now, this particular function belongs to a family of functions in R. They are like this. They start with R followed by an abbreviation of the name of the distribution. So if you want to look up the help, you can do this question mark R norm. And then you will get this help. And here you can see that there are 4 such functions. One is called D norm, another is called P norm, Q norm, and R norm. R norm generates random normal numbers, D norm gives the PDF, P norm gives the CDF, and Q norm gives the inverse CDF, that is the quantiles. And all the details are given later, what is meant by what. And this is a general rule in R. For every distribution or every standard distribution, we have a D function, a P function, a Q function, and an R function. For example, if I want to generate from binomial, I can use R binom. And there you similarly have D binom, P binom, Q binom, and R binom. D binom will give you the PMF, P binom will give you the CDF, and so on. Anyway, so here what we are doing is to generate 100 standard normal random numbers, and then I do the same thing with y, but here I multiply it with 2, so basically the standard deviation is 2. And then I have z equal to r norm, again 100, but now the standard deviation is 0.1. So I multiply it with 0.1. So I get x, y, and z. Now I want to visualize these things. The way I have created them is this, that x has some spread, y has even bigger spread, but z has very little spread. So all these 3-dimensional points, if I consider them as 100 points, they are basically lying on the xy plane with a little bit z component. I just want to see how that is. So in order to visualize that, I will load a library called RGL. Now this library is not part of R by default, so you have to install it once for each machine. Now I had already installed it, so I do not need to do it again, but this is how I install it. I wrote install.packages, then within quotation, either single quotation or double quotation, I have to write RGL and I have to hit enter. Of course my computer must have internet connection at that point, then it will download from appropriate websites whatever stuff is needed and all its dependencies, etc., etc. And if your machine is capable of showing this dynamic graphics, in that case it will install correctly, otherwise it will give you an error message. In my case it did install more or less perfectly, except that my machine does not have the 3D graphics capability directly, so it has complained, this build of RGL does not include OpenGL functions, I have to use something. So whatever something they suggest that I should use, I am going to use that. They say I have to use options, etc. So I will do that without understanding much, say. So I will just type that here, nothing happens. So this basically says redirect all your outputs to an HTML file so that we can drag it using your browser. Okay, anyway, let's continue. Now we have an open 3D. So this open 3D thing will actually create the output. For me, it is not creating anything because my machine is not capable of OpenGL. So I'll have to copy this line also. And then I see that I have got a browser window which is blank. So Open 3D just opens a blank window. Okay, now I have to go into the interesting stuff. I write spheres 3D xyz rad equal to 0.1. Let's see what it does for me. Well, it creates these things. So it considers each case, that is each value of x, y, z as a case. So x1, y1, z1, that gives a triple. A position in three-dimensional space, x2, y2, z2 is another position. In this way, I have got 100 positions, 100 points. At each point, it draws a sphere of radius, whatever, that's 0.1. Now, this picture I can drag with my mouse. So, you can see that in the z direction, there is hardly any scatter. Okay, now this is not very interesting in the sense that this just lies flat on the xy plane. I want it to be somewhat obliquely placed. So it is still going to remain in a plane, but the plane will be oblique, so that just by looking at the data you cannot say, oh, the z values are essentially all zeros, throw them away. I want to hide this feature that everything is really on a plane. For that I will give it some rotation. Now, rotation means I have to multiply the things by some orthogonal matrix, 3 by 3 orthogonal matrix. So, I create a very simple 3 by 3 orthogonal matrix like this. I take the first column to be 1 by root 3, 1 by root 3, 1 by root 3. That's a simple unit vector. Then the next column I take 0, minus 1, 1, 1. That is orthogonal to the first one, and to make it unit vector, divide by root 2. And the last column I take minus 2, 1, 1, which is orthogonal to the last two columns, and also in order to make it a unit vector, I divide it by square root of 6. So I take this thing. So let me load it. I will show you what R I get. This is my orthogonal rotation matrix. Now I will create my data set. So I have the x column, the y column, the z column. That makes a matrix 100 by 3. I want to post multiply that by R so that it multiplies each of the rows. And that is done in this way. So just observe, when I say C bind, that means bind as column. So first column, second column, bind them side by side. If I say R bind, then they are bound one on top of another. They are stacked one on top of another. And then this is the matrix multiplication symbol in R, and I multiply this with the rotation matrix, so I get that. Let's quickly check its dimension by the dim command. It is indeed 100 by 3. Okay, so now I want to take a look at the resulting data set by plotting it. So I am now going to use plot 3D. I earlier used spheres 3D, which was pretty good, but the main problem with spheres 3D is that it does not draw the axis lines, and I want the axis lines. So I use plot 3D, which basically just plots the thing, and I get the same thing, except that now they are plotted with very tiny points. So if I rotate it, you can still see that they are basically on the plane, but that plane is not parallel to any of the coordinate system, coordinate planes, because I have rotated it. Okay, that's basically all. Now I want to save this data set into a file so that in the next video I can load it and work with it, or I can share it with others. Now the data set resides in the variable called dat. If I just type dat at the prompt, I will get the entire data. Now I want to send this thing from the screen to some file, and the way to do that in R is to use the sync command. Here is the sync command, SINK, and if after parentheses you write the name of some file which may or may not exist. In that case, it will create a new file of that name. If there is an old file of that name, it will silently delete it. That's what I'm going to do. So it deletes any file called pca.dat in my current directory, and it redirects everything of my screen. My screen means whatever comes as the text output. It will redirect it to that file which I have called pca.dat. Then I will hit F7. So now you see, though I wrote dat, it did not show anything on screen because everything is redirected into pca.dat. Finally, I have to bring the output back to my screen by giving the sync command again, but this time without any argument, just open parenthesis. Okay, let's quickly see what's inside pca.dat, and I can see that pca.dat is indeed this with some rubbish at the start. I will get rid of that, and I might as well give them names. X, the first variable is X, the second variable is Y, the third variable is Z. Of course, it is possible to make R give the names. And these things, the row numbers, since they are inside square bracket, they are not going to cause any problem. So I have created a file called pca.dat, and we are going to work on that in the next video.